Hi, Jason from my studio. Welcome to this new video. This is the part 2 about flex in with pop. And in the last video, we explored my experiment. And this time we try to recreate something that makes sense. I throw here already some boring stuff, which of course you can have for free, right? Following pattern, but I create a pool of object. The only interesting thing is this one. Okay, so now we do this together, and then you got the idea. So I drop any shape, and what we want to achieve is to add this shape to add to a shape which is a stream of attribute, some new attributes, which are the color and the for the point. The most important things we do is not the color, but the ID. So, for example, drop a sphere, you attach an attribute. And inside here, we can drop a color, which you can define as we want, like that. The second thing we want to do is to create a custom attribute, only with the field, an ID from the p. We want it as an integer, and in this case, it's 0, but be anything. Okay, you have to remember which is which one. The trick I did here is to create a box from a sphere, since then you can keep the normals on point and the looks rectangular. Because not very much flex related, but here the normals are in vertex, which is bad. If you then do it on point, you get interpolation, not making the angles of the box be sharp. Okay, but if you then quantize a sphere in that box with the right normals on the point size, maybe here it's a bit like that, but we don't care much. Same here. So if you move this, for a tube, having the point, having the normals on vertex or on point doesn't really matter. Okay, it matters on the bottom part. Okay, which we want, which if is in point is better. So you need to create something that looks good, which is a circle, and throw it on it. So that is good. It's flat, but it's on point. We want to keep all the normal in point stage because then it's faster for us to move it around, and also because the other stuff we're using, they have the normal on point. This setup. So then when you merge it, the merge try to say to keep the string consistent. So if you have an attribute which is not in a family, let's say point, vertex or primitive, if it's not in one of those predefined location, copy it to usually the smaller one. It's not consistent. Okay. So now we're good, and we have all the normals here, because I don't want to recalculate them if I have them when I copy. That's why I spend some time in this. Okay, and the demonstration on how to texture coordinate, no, that coordinate, yes, on point. So what are we doing here? I'm showing you the trick of the UV in a consistent way, which we can. So you see we have the same result here and here. Okay, it's the same. Maybe it's a bit smaller, but yeah, we can zoom it. I say this because so this is with the UV. Okay, maybe what interpolate. Yes. So we are using the UV of the plane to read this big texture, and here I'm actually calculating those UV for a buffer, which is the same size of the incoming um, plane or whatever grammatical stream. We want to use it with particles. That's why you have the incoming particle in a square. That is nice. So the buffer matches this. And with the trick I show you with the modulo and the division, you can read it. This over is actually just used as the size. Because if you mark, you can then say, use the input to layer, and then we get the actual size we want for the buffer at the time. So here we made your input data, texture, color, wherever, and you can also see that it's looking tiny better. Well, we are shrinking everything. It's more aligned. Or the interpolation you get from it. If you're working with more stuff. Okay, it's like 20 times 20, so that's very nice. You can of course like offset it. I guess this goes with, yeah, nice worked. Okay, and here you set what you hold maybe. Okay, here you need to move, since I defined it for pixel index, you need to add one integer per time. So I'm moving 10 units. Okay. The auto sample text, if you do not have text coordinate, you need to set the buffer, same dimension, and do a square thingy. Okay. We will continue our example, finally get our net dirty with the GLSL copy of glass of water for me. Okay, I'm back. GLSL copy, yes. GLSL copy. Okay, you drop it is in an error state is fine. So yeah, I thought they keep this since we have an attribute already the color. So maybe the color we delete from a template as well. Okay, so now we are doing some stuff which is not what we wanted, because let's split this, put the geo, and this guy go up, and we have this 37. This I may need to clean a bit of memory per now. So okay, now it's correct. I'm still experimental by the way. Okay, so we're doing this. Why we're doing this? Because the code is telling the compute shader to do this. So shift it for some value which we need to increase the move more or even more. That's space in between. Each repetition shift the same amount. That's what's yeah, very much destroying everything. This is just oops. Okay, yeah, I did a lot of them apparently, because we're doing this for all the points. So yeah, a lot. We don't want this. Okay, so we would like to for example, take and make a copy just for the, so we start to copy each one of the, all of those. Okay, so precise. To do this, we can read the template position as well. dd template underscore e, and theoretically now we are making this block of geometry. Okay, we want to pass the normal, since here we fight for it, okay? We're fighting for them. Um, yeah, you need to tell the complete shader that has another output. So in that point out, out attributes, you need to add the name of n, which are predefined attribute naming convention level top, so n refer to normal. So then here, make it big, super big for you. I want to add the normal as well. How to do this? Is that maybe, and we say that this is for the normal of the compute shader. We just want to read the normal or the incoming emoji element, which always plus semicolon here. We don't need this. So, all right. Very clean. This is what you need. And if I didn't make any mistake, you have to call n. So again, we refer to the input. In this case, the naming convention is the template is the first input. This is the second input. So the mesh you want to copy and where you want to copy, they have to be the same. Yeah, like this. Oof. And here we are. We have now the normals. Okay. We can then do the grid bigger. So for now, let's close the code. Let's size it. Take our time. So optimizing is very big. That's the beast. It did. Pancake. Big. Very big. Okay. And then now you can see that they are all dependent from here. So I drop a transform. They are all the same. Okay. So some nice effect, by the way. Okay, so we have this, but we don't want this. Let's make it fancier. Okay, let's add a probability. So look up texture. Okay, so we know we can do the same things here and use this string instead of the color. We can get texture containing the probability of being a shape or another shape. You know, this with the noise. And we take this, no, noise stop. Noise stop. Why noise stop? Because it's scalable. I see the value, but right, we just want to add to noise. This noise has to be, we want to have good value. And I want something which is 0 or 1. Oh, maybe even more than 1. We clamp yeah, so then we clamp this 0 or 1 with we need my unit 0 1 clamp 0 1. Yeah, nice. Again, packet that teaches us that nearest pixel is important sometimes. Almost all the time you want to make precise calculation, not always. Yeah, then we want to count what shape we have. In our shape pool, alt, let's click the shape pool, okay, shape pool, right click, parameters, clicking in the menu, now text, which guy, yeah, shape pool guy. Nice. But so how many shape do we have? 0 1 2 3, starting from 0. We have to write to 3. And then we take a math. we say that we want to go 0 to 3, and we want to next pixel again. Then we want to check if the probability are correct. All three. So 3, 3, 3. A bit too much. So maybe we do want to actually make the exponent like so. And now we start to have a number in between, which we can then, with this math, we say ceiling. So, so 3, 1, 2. Okay, yeah, we start to have order of 3 possibilities, or of 4 possibilities: 0, 1, 2, and 3. Not much too, so maybe wait, or outline. So 1, 3, 1, 0, 2. But you can fine tuning later by defining the noise a bit more consistent. But yeah, let's continue. Precise, we drop this math, which is not a color, is our probability. And then we write some code. Let's write some code. And the code we want to write is enable the usage of some attributes. Let's define them. Papa EDP, and it is from the in, which is the first input. So actually we don't even need it because we just need it there. So let's compile a new statement. Let's write a condition. The condition is inside the parentheses. You can keep it attached or not, doesn't really matter. Compile doesn't read spacings, does not read spacing. This is why you have those. Close the line. So the if statement is inside here with the if inside of the statement. All right. We want to leave the incoming template probability. So TV template, I call it prob to be consistent with the other example, and then embed here into this. Well, always find an error that EV.EVP and you release. Okay, let's see. Of course. Yeah, so we have actually, we need to mask values because it's just like so. We need to mask some values and then it's working. Yay, well, that's, why do we need to mask some value? Because the probability is a monochrome, it's one integer, and we were passing back 4. So yeah, you need to go in the lookup and mask everything but events, which is now dependent from this noise. Very nice. Take a bit of space. Yes, but this to 0, populate. Make this smooth. Yeah, if you, yeah, this is the problem I show you last time, that you can't change the probability real time because you're actually changing the stream of the stream of the which incoming set of point you need to process, which is if you change this again, just say we are actually populating those, we need to go through the memory all the time. And this is not very much friendly sometimes, especially so you can't do it at time. It's take a probability by the beginning of this. Maybe when they update it, this may be better. So now I select everything and bypass it. So to really my unfortunately. Yeah. Okay. So this is how to copy multiple objects with a copy and read it from a texture buffer, which is always the size of what you need. If you're working with the read, but I guess if you put a null here, then maybe we need to go orientation, which is kind of probably 20 minutes to third. Here, as I said, we have a fruit here. Okay. So yeah, that we need to make the sky very much big. But yes, it's working also here. As you can see, working with these guys, with tricky. If you change the geometry stream, but yeah. Yeah, I bet if we can orient them somehow, we have the normals. Yeah. Let's see if we can orient them on the fly. I guess if you then this one views we now read the template normals from the sphere. But theoretically, well, now because you need to rotate for that vector. Yeah. Next time. Okay, next time we will orient them better, but yeah, this is how to copy multiple objects with the GLSL copy and some ideas. Here, well, we have colors, so let's drop some colors where color, so then you can, why you said, bro? There's not that pre-processing color, apparently. Okay, it's not typing. Because it's not creating color, but then we create a flipping color, flip color. And then, so I go to colors, we create the color. And then I guess we can, what is that? Right. All right. Yeah. Okay, nice. Now we are like we are putting colors. I don't know what to do, but yeah, we now have colors. So yay, nice. Let's clean this. There's a screen memory. So yeah, you can experiment some higher rendering. It's not pretty much perfect, but it will be. Yeah. Okay, now we have colors. Which are those, don't know very much why they're those, but we can address them by say color, DD, and get the right color for red sheet, which we can export from the color, export color, and this should, yeah, put red color on the red sheet. Very nice. Yeah, I can make a break if you should do. Then we already have that, right? Yeah. Okay, I'm back. Yeah, now we need to rotate those thingy of, yeah. So each object has its own orientation and can be rotated. We need some um, function which we have to find. Yes, a bit even. Uh, rotation. Yeah. So we need these basically ingredients. Maybe rotate X and then X and blah blah blah. Nice. Um, I actually don't know if um if I pass the normal to this, then it's okay for radius. I don't know. We will rotate them. Then we see if we can actually orientate them with the normals. I'm not very much sure, but yeah. Um, so the rotate X with bigger. Okay, so this is the code. Let's get a bit. Okay. So now here we want to create some matrix, so map 3, I guess. Yeah. Why? Because because then you can apply this matrix to a vector, so to rotate the definition. We call this map x. Okay. Or actually, let's make it better. Yeah, we can make it better because we already have a function which is so those are these in where we are the mesh basically. So then keep this. So um this is the actual piece of the it's here. Okay. So you see I am rotating all of them for a radian value of 1.5. Okay, so fact all of that in the X. Okay, so if we uh, then have an attribute which needs to be in radius, but it's a value that goes from, I guess, you can make it that goes from minus to pi to pi, something like this. So you have the double spinning, and this is the noise we want to have. So it's nice. Yeah, let's do this. Very good. Okay, let's make everything rotate noise into the noise. Yeah, it's nice. Okay, let's compile this first so then we can replace other stuff later. Our goal, take a noise, the texture that is taking care of the rotation of our copied geometry. Copied geometry. Okay, nice. With this times, we could actually compile a map 3 with internal map 3, but yeah, where the geometry, the actual transform. Let's also think real life where so these three functions, let's say that we are rotating, we should also rotate the freaking normals for the same, because then we still attached to the geometry. Very important here. Not power. That's nice. Okay. Yeah. Um, so then there's the normal state attached to the surface. Um, these things, what we're writing here is this one. Geometry. You see, we're rotating stuff. As you can see, we're rotating also the normals. You don't know it, but you're doing this, right? Same things, we just writing it inside of the direction property. Okay, and then we can address it with attribute that we now create. Okay, code is would now close it, nice. Ace for center. Okay, nice. Finish. Then we have a buffer. We can just do another buffer. So you copy this. This guy is now not monochrome anymore. We'll see later the right value for it, whatever. It will move randomly. Why do we have a math here? I don't want a math here. And they call this route for rotation. Route. Capital. Copy this guy. Take this guy, drop it here. And instead of follow this route, and we're good. We have another buffer. Oh, nice. Okay. Let's open the code again. Okay. Since we are repeating this, I guess we will store it in a variable. It's not this freak out. So we have everything inside the route. So we create a float for route x, route x. Yeah, sounds good. Which we define as if in the template. Yes. Yeah. Here for route and x. Suppose take this guy, repeat 3 times, and compile the thing here as we want. Or support to. So, then now we are splitting the 3 part of the vector because we need to rotate each axis separately for the piece of the job. Okay. Nice. Then we can just throw this in under x, which is rotate it. We copy this guy here, we copy this guy there, then we take the y, we copy this guy here, we copy this guy there, wrong here, yeah, then we take the z, then we copy it here, and overwrite my error. Sounds good. Let's see which one to go. Okay. Epsilon. It's not good. Why? And because I copied this and this was for 1 vector, but we have 3 vector now. And not in this one. Oops. But in this one. So 3. Right. Yes. Okay, nice. So we are rotating stuff. Let's see if they are actually rotating as we this is very, very random. So let's do this. And then it's very noisy. But hey, they're around. That's nice. Time the spectrums. Word. Divided the 415. Yeah, something nice. Then they are rotating around the sphere, moving, doing stuff. Yeah, and I'm gonna make this like more better. Yeah, here you can you can actually uh, should take a map here and like the range, I guess. Yeah, you can like range how much they are rotating for each axis. Okay, nice. So we copy some geometry into a sphere, different type of geometry on a sphere, and yeah, maybe we can rotate those back like this. You got the idea. Thank you for your attention. Please support my channel. I give to charity what I get. Thank you. Ciao.